Project costing. In this animation, we are going to see about project costing, cost estimating. A cost estimate is a prediction of the likely cost of the resources that will be required to complete all of the work of the project. Cost estimating is done throughout the project. Types of estimates. Depending on the accuracy required for the estimate and the cost and effort that can be expended, there are several choices. Top-down estimates, bottom-up estimates, analogous estimates, parametric estimates. Top-down estimates. Top-down estimates are used to estimate cost early in the project when information about the project is very limited. Bottom-up estimates. Bottom-up estimates are used when the project baselines are required or a definitive type of estimate is needed. Analogous estimate. Analogous estimates are a form of top-down estimate. Parametric estimates. Parametric estimates are similar to analogous estimates in that they are also top-down estimates. Example for project costing. In this video, we are going to see about examples for project costing. A project cost accounting system provides a means to accumulate costs by project and project activity or task detail. If any company does not have a project cost accounting system, they can plan their project costs with project management or spreadsheet software, but they will not have any practical way to monitor the actual costs. The following are the elements of such a system. Labor, people in your own department, other people in the company, overhead burden, non-labor, purchases, subcontracts, travel, computer charges, general and administrative burden. There are many variations in detail for project cost systems, some of which are shown in the figure. We are making the simplifying assumption that the organization has 3 projects A, B and C that all start at the beginning and will end at the close of the fiscal year. It does not matter whether the work is for the company or for an outside client or whether it is to be paid for by the sale of goods contract billing. The point is that there has to be some way of allocating the cost of these illustrates 4 methods of allocating these costs to the 3 projects. In method 1, the direct labor and direct non-labor are allocated to the project and these are summed to provide a direct total. All the burden and overhead accounts are then lumped and apportioned to each project in proportion to the direct total expenses. In method 1, these are equal and the billings to each of the 3 projects would be equal. In method 2, the direct labor and direct non-labor are treated as before, but the overhead portion is allocated to each project in accordance with the amount of direct labor it requires. Nevertheless, the general and administrative, the G&A expenses, are allocated to the projects in accordance with the direct total as in method 1. In this case, the billings to the projects are not equal. Project A is more than the project B, which is more than the project C. In method 3, the overhead is treated as in method 2 and the direct non-labor is treated as in both methods 1 and 2. In this case, however, all these items and direct labor are joined to come up with a prime cost, and the G&A burden is allocated in proportion to that. In this case, we will arrive at a still higher amount of billing for Project A. Method 4 is one of the many common variations of Method 3. Direct labor and overhead are treated as in Method 3, but purchases are subjected to materials handling charge. But other direct non-labor, in this case, travel is not allocated a handling fee as illustrated in Project C. This results in a still different prime cost. Finally, the G&A expenses are again distributed and a still different billing arrangement is arrived at. The project manager must understand his or her company's method in order to know when to use subcontract help and when to use in-house direct labor. It is also important to understand any subcontractor's cost accounting system. If you are placing a labor-intensive contract with a subcontractor, you should not use a subcontractor who practices Method 3 as opposed to Method 1. Software project estimation. In this animation, we are going to see about software project estimation. Estimation of resources, cost, and schedule of software development are very important. To make a good estimate, we require experience and expertise to convert qualitative measures to quantitative form. Factors like project size, amount of risk involved, etc. are affecting the accuracy and efficacy of estimates. The following are the different techniques for estimation: empirical estimation techniques, decomposition techniques, automated estimation tools. Empirical estimation techniques. Estimation models uses empirically derived formulas to predict the estimates. The structure of empirical estimation models is a formula derived from data collected from past software projects that uses software size to estimate effort. Size itself is an estimate described as either lines of code, that is LOC, or function points, that is FP. Constructive cost model, that is COCOMO. Model 1, Basic COCOMO. Model 2, Intermediate COCOMO. Model 3, Advanced COCOMO. The Basic COCOMO model computes software development effort and cost as a function of program size expressed in estimated lines of code. The Intermediate COCOMO model computes software development effort as a function of program size and a set of cost drivers that include hardware, personnel attributes. The Advanced COCOMO model incorporates all characteristics of the intermediate version with an assessment of cost drivers' impact on each step, that is analysis, design, coding, etc. of the software engineering process. Decomposition techniques. Here we subdivide the problem into small problems. When all the small problems are solved, the main problem is solved. Lines of code. Function point. LOC, lines of code. FP, function point. Estimation methods consider the size as a measure. In LOC, the cost is calculated based on the number of lines. In FP, the cost is calculated based on the number of various functions in the program. Automated estimation tools. The decomposition techniques and the empirical estimation models can be implemented using software. These automated tools allow the planner to estimate the cost and effort, will also give important information like delivery date, staffing. Work breakdown structure, that is WBS. In this animation, we are going to see about work breakdown structure, that is WBS. There are two methods in the work breakdown structure, WBS. Dividing into logical units or tasks. Benefits of using a WBS. Dividing into logical units or tasks. To correctly estimate the effort, size or cost of completing a project, it is most important to be aware of the multiple tasks that comprise a project. You can divide a project into logical units or tasks by using the WBS technique. Creating a WBS is a prerequisite for any estimation activity. It enables you to conceptualize an abstract entity such as a project into distinct, independent units. After dividing a project into tasks, you can characterize them as logical both tasks. For example, tasks such as drawing up a marketing strategy, planning a phase-wise product release, and interacting with media agencies and the product department can be compiled under a common category, marketing. Benefits of using a WBS. Using a WBS provides a number of benefits to the management and to the development teams. First, it gives the management an idea about the size and complexity of the project. Second, it helps in planning, scheduling, and monitoring a project realistically. This is possible because all the tasks in the project can be performed, measurable tasks for each task. To aid planning, scheduling, and monitoring a project, you can use tools such as program evaluation and review techniques, that is PERT, critical path method, that is CPM, timeline charts, Gantt charts. These tools use WBS as the fundamental basis for assessing resources to tasks, computing the number of days needed, and the cost required to complete the task. Measuring effort for a project. In this animation, we are going to see about measuring effort for a project. Measuring effort for a project. Measuring the effort for a project is a specialized activity. It enables you to derive cost estimates that are critical for the project management. An incorrect measurement of effort at the beginning of the project can result in inaccurate project plans and frequent slippages. It can also lead to inaccurate cost estimates, which can cause steep cost deviations between estimated and actual cost values. There are many techniques that you can use to accurately estimate effort, such as source line of code, SLOC, function point, FP, constructive cost model, COCOMO, SLOC technique. In this animation, we are going to see about SLOC technique. SLOC technique. At the beginning of a software project, it is important to determine the size of the project. The project size helps determine the resources, effort, and duration of the project. There are many techniques to calculate the size of a software project. You can calculate the size by using a directly measurable technique, the SLOC technique. It is defined as the source lines of code that are delivered as a part of the product. The effort spent on creating the source lines of code is expressed in relation to 1000 lines of code, that is KLOC. The SLOC technique is an objective method of estimating the size because there are no multiple ways of calculating the lines of code. Therefore, the effort estimate is close to being accurate. This technique includes the calculation of lines of code, documentation of pages, inputs, outputs, and components of a software program. Components are again of multiple types such as reports, screens, and files. The SLOC technique is also used to directly calculate the effort to be spent on a project. Following figure is a simple example of counting source lines of codes. The code displayed here contains 4 lines of code. If employee code is less than or equal to 1200, print welcome to the inventory database, else print access denied to the inventory databases. You can use the SLOC technique to estimate the effort required for a project when the programming language and the technology to be used are predefined. In addition to the programming language and technology, the complexity and effort required to write a program should be easily predictable. The use of the SLOC technique requires that the technology or language remains unchanged throughout the project. Generally, you can use the SLOC technique when you are using third-generation languages such as Fortran or COBOL. Disadvantages of using SLOC. Despite being accurate in providing figures to calculate the effort required for a project, the SLOC technique has a drawback. The SLOC technique is language dependent. The effort required to calculate source line of code may not be the same for all the languages. For example, to conceive and write 8 lines of code that accomplish a task in the assembly language may require 15 minutes. However, you may need only 5 minutes to complete the same lines of code if it is written in Visual Basic. Function point FP technique. In this animation, we are going to see about function point, that is FP technique. The FP technique is a direct indicator of the functionality of a software application from the user's perspective. This is the most popular technique used to estimate the size of a software project. You can use the FP technique to estimate the total size of a project. The total size of a project is estimated as a single FP value. After calculating the total size of a project in FP, you divide the total FP into different phases of the SDLC. This way you can determine how much effort per FP is required in that particular phase. For example, the testing phase is planned for 20 FP of work. The project managers, based on their past project experience, determine the amount of effort in man per person months required in the testing phase. Similarly, you can express the cost required to complete FP of work for a particular phase. At the end of a project, you can also express the number of defects reported in terms of per FP for a phase. Features of function points. The total size of a software project is expressed in total function points. It is independent of the computer language, development methodology, technology, or capability of the project team developing the software project. The specific user functionality of the application is evaluated in terms of relation to what is delivered by the application and not how it is delivered. only user-requested and user-defined components are counted. To calculate FP, some major components are required. The major component and their relationships are represented in the following figure. You can calculate the function point estimates for a project or a particular phase by following 4 steps. Identify the unadjusted function points. Calculate total GSC. Calculate value adjustment factor, that is VAF. Apply a formula to calculate adjusted FP, that is AFP. Advantages of using function points. Disadvantages of using function points. Function points are language and technology independent. Therefore, you can use them to estimate any kind of project. Estimation by using FP generally uses data from past projects for assigning weights to GSCs and the information domain values. They can also be used to estimate the effort, cost, and schedules of projects that use the prototyping and spiral models because such projects have uncertain user and project requirements. To be able to do this realistically, it is important for the organization to have developed similar projects in the past. In addition, you can use function points as a project estimation techniques when you anticipate changes in the middle of a project. These changes may disturb the estimates if you had used SLOC to estimate the effort, cost, or size of a project. The organization should also be prepared with adequate data and tools for FP estimation of the new project. The FP estimation uses a subjective and holistic approach for project estimation. In addition, FP provides a vague estimation. This characteristic of FP does not usually provide precise or approximate estimates of the effort, cost, and size of a project. Consequently, the estimates calculated by using the FP are unlikely to be incorrect. Consequently, at the end of a project, deviations from the estimated to the actual values of each of the factors may be quite extreme. Properties of estimated tools. In this animation, we are going to see about properties of estimated tools. In general, the tool should have the following properties. Allow easy adaptation to an organization's development environment. This means the tool needs to be capable of being customized to fit the organization's development environment. Customization includes allowing the developer to define applicable inputs as well as allowing modifications of coefficients and exponents of the equations used by the tool. This feature will allow continuous improvement to the estimation capability of the tool since the organization's historical data and current project data will be included in the software estimate generated. Be relatively easy to learn and use. The tool should be well documented and should include reference material for the methodologies and equations used. Documentation should be at a level that is understandable. The tool should include help menus and examples sufficient to assist the support staff in answering questions and providing training. The amount of formal training required to use the tool should be relatively minimal, required input should be well defined, and visibility into internal equations and theories should be provided. Provide early estimates. The tool should be capable of generating estimates early and quickly in the lifecycle process when requirements and development environments are not fully defined. The tool should also allow task detail to be added incrementally as functions, activities, and other information becomes more completely defined. Since there are many unknowns early in the estimating process, the tool should reflect degrees of uncertainty based on the level of detail input, that is, risk analysis. Be based on software lifecycle phases and activities. The tool should be capable of providing estimates for all phases and activities of the most commonly used software lifecycle models. It should allow the organization to decompose and map software development tasks into those phases and activities, as well as support a project WBS. In addition, it should allow for what-if situations and include factors for design trade-off studies. Allow for variations in application languages and application function. It is very important that the tools provide estimates specific to the application of the software project, since the associated estimating equations, cost drivers, and lifecycle phases should be unique to each application area. General application categories include information systems, that is IS, simulation and modeling systems, real-time systems, accounting systems, and systems based on higher order languages. Provide accurate size estimates. The size of a software development project is a major cost driver. In most estimating tools, its size is one of the most difficult input parameters to estimate accurately. The tool should include the capability to help estimate the size of the software development project, or at least help define a method for estimating the size. Provide accurate schedule estimates. The software estimating tool should be able to provide schedule estimates accurately. The purpose of scheduling is not only to predict task completion given task sequence and available resources, but also to establish starting and ending dates for the associated work packages and lifecycle phases. Provide maintenance estimates separately. Software estimating tool should be able to provide software maintenance estimates as a separate item. Software maintenance includes such activities as correcting errors, modifying the software to accommodate changes in requirements, or extending and enhancing software performance. Automated estimation tools. Comments. Automated estimation tools allow planners to estimate effort, cost, and schedule. What-if analysis facility greatly enhances usefulness of the tools. General characteristics of estimation tools. Sizing of project deliverables. Selecting project activities. Predicting staffing levels. Predicting software effort. Predicting software costs. Predicting software schedules. Algorithmic method. In this animation, we are going to see about algorithmic method. The algorithmic methods are based on mathematical models that produce cost estimate as a function of a number of variables which are considered to be the major cost factors. Any algorithmic model has a form. Effort is equal to f of x1, x2, and so on up to xn, where x1, x2, and so on up to xn denote the cost factors, that is, software metrics. The existing algorithmic methods differ in two aspects: the selection of cost factors and the form of the function f. These models work based on the S-special algorithm. For years, many models have been developed, some of which are COCOMO model, COCOMO 2, Putnam's model, and SLIM. COCOMO model. COCOMO, Constructive Cost Models. This family of models proposed by Barry Boehm 1981, is the most popular method which is categorized in algorithmic methods. This method uses some equations and parameters which have been derived from previous experiences about software projects for estimation. The models have been widely accepted in practice. In the COCOMOs, the code size S is given in 1000 LOC, that is KLOC, and effort is in person-month. 3 models of COCOMO given by Barry Boehm. Simple COCOMO, Basic COCOMO model, Intermediate COCOMO. Simple COCOMO. It was the first model suggested by Barry Boehm, which follows following formula. Effort is equal to A into KLOC power B, where S is the code size and A and B are complexity factors. This model uses 3 sets of A, B depending on the complexity of the software only as given in Basic COCOMO model. The basic COCOMO model is simple and easy to use. As many cost factors are not considered, it can only be used as a rough estimate. Intermediate COCOMO. In the intermediate COCOMO, a nominal effort estimation is obtained using the power function with 3 sets of A, B, with coefficient A being slightly different from that of the basic COCOMO as shown in table 2. Previous model does not include the factors which can affect the efforts. Effort is equal to A into KLOC power B into EAF. EAF is the effort adjustment factor used in intermediate COCOMO. The overall impact EAF is obtained as a product of all individual factors. Typical values for EAF range from 0.9 to 1.4. The detailed COCOMO works on each subsystem separately and has an obvious advantage for lot systems that contain non-homogeneous subsystems. COCOMO 2. Number of effort adjustment factor R increases by 5. Now it becomes 22 as shown in table 3. Putnam's model and SLIM. Putnam's model is proposed according to manpower distribution and examination of many software projects. Software equation for Putnam's model is as follows. S is equal to E into effort power 1 by 3 into TD power 4 by 3, where TD is the software delivery time. E is the environment factor that reflects the development capability which can be derived from historical data using the software equation. The size S is in LOC and the effort is in person year. Another important relation found by Putnam is effort is equal to D0 into TD cube, where D0 is a manpower build-up factor which ranges from 8 new software to 27 rebuilt software. Combining about 2 equations, final equation is obtained as effort is equal to D0 to the power 4 by 7 into E power minus 9 by 7 into S power 9 by 7, and TD is equal to D0 power minus 1 by 7 into E power minus 3 by 7 into S power 3 by 7. Putnam's model is also widely used in practice, and SLIM is a software tool based on this model for cost estimation and manpower scheduling. Advantages and disadvantages of algorithmic method. In this video, we are going to see about advantages and disadvantages of algorithmic method. Advantages: provide reliable estimates based on data from earlier projects or based on objective and repeatable formulae. Types of algorithmic models: tabular or analytical, linear or nonlinear. Useful during early project stages, in absence of complete data, for providing envelope for making trade-off decisions. Useful during later project stages, for verification of earlier estimates, for estimation of remaining phases. Main advantages: amenable to automation, easy to use, calibrated to previous projects. Disadvantages: it relies on the estimates of some parameters. For example, estimating lines of code of finished software is difficult during early stages. Controlled experiments are expensive and difficult. Dependence on the correctness of the inputs is high. Reliability of input metrics is the key to success. Parameter valued tend to be highly organization independent. Cannot handle exceptional conditions. For example, takeover of an incomplete project with no prior records. Calibrated to past projects and not to future. Impact of new technologies is difficult to judge. Limited usefulness of past data in the light of advancing technology. Estimating effort and duration is difficult for new technologies. Tend to be domain specific. For example, only for estimating software effort component of an IT project.